Have you ever looked up at the night sky and wondered about space? The twinkling stars, the distant planets, the vastness of it all? It's a sight that has captivated humans for millennia. Each star, a distant sun, each planet, a world of possibilities. The night sky is a canvas of dreams and mysteries waiting to be explored. The vastness of it all is both humbling and inspiring. It makes us realize how small we are in the grand scheme of the universe. Yet it also ignites a spark of curiosity and wonder within us. What lies beyond those twinkling lights? What secrets do the distant planets hold? These questions have driven humanity to look beyond our world and dream of the stars. It's no surprise that humans have always dreamt of traveling beyond Earth. From ancient myths of gods and heroes journeying through the heavens to modern science fiction tales of interstellar adventures, the idea of space travel has always been a part of our collective imagination. We long to explore the unknown, to see what lies beyond the horizon, to push the boundaries of what's possible. We long to explore the unknown, to venture into the vast expanse of space and uncover its secrets. The desire to explore is deeply ingrained in our nature. It's what drove our ancestors to cross oceans and climb mountains, and it's what drives us today to reach for the stars, to push the boundaries of what's possible. We have developed incredible technologies and embarked on daring missions. From the first satellites to the moon landings, each step forward has brought us closer to realizing our dreams of space exploration. The journey has been challenging, but the rewards are immeasurable. For centuries we've gazed at birds soaring through the air and wished we could join them. The dream of flight has always been a powerful symbol of freedom and possibility. It inspired inventors and pioneers to create machines that could lift us off the ground and into the sky. Now, we have airplanes, incredible machines that let us travel the world. These metal birds have transformed the way we live, work, and connect with each other. They have made the world smaller and more accessible, bringing distant places within our reach. But can these metal birds take us all the way to space? The dream of space travel is no longer just a fantasy. With advancements in technology and the determination of visionaries, we are on the brink of a new era of exploration. Let's find out what the future holds and how we can turn our dreams of the stars into reality. Airplanes are marvels of engineering, but their ability to fly depends on a simple principle: lift. Lift is the force that directly opposes the weight of an airplane and holds the airplane in the air. It is a crucial component of flight, and understanding how it works can give us a deeper appreciation for the complexity and ingenuity behind aviation. Imagine holding your hand out of a car window. As the car speeds up, you can feel the force of the air pushing against your hand. This is a simple way to experience the principles of lift and aerodynamics firsthand. If you tilt your hand slightly, the air pushes it upwards. This is because changing the angle of your hand changes the way the air flows around it, creating a difference in pressure that lifts your hand. Airplane wings are designed to do just that. They are meticulously engineered to create lift efficiently and effectively. The shape of the wing, known as an airfoil, is crucial in this process. Their curved shape forces air to travel faster over the top of the wing than underneath. This difference in speed creates a pressure difference, which is the key to generating lift. This creates lower air pressure above the wing and higher pressure below, resulting in lift. The greater the difference in pressure, the more lift is generated, allowing the airplane to rise into the sky. Of course, lift alone isn't enough. To achieve and maintain flight, an airplane also needs thrust. Powerful engines provide the thrust needed to push the plane forward. Thrust is the force that propels the airplane through the air, overcoming the resistance it encounters. Overcoming drag, air resistance, and keeping it in motion. Drag is the force that opposes an airplane's motion through the air, and it must be overcome for the airplane to continue moving forward. By balancing lift, thrust, and drag, airplanes can achieve the incredible feat of flight, soaring through the skies with grace and precision. Airplanes need air to fly. It's the air pushing against their wings that generates lift. But here's the catch: the higher you go, the thinner the air gets. Earth's atmosphere, the layer of gases surrounding our planet, isn't uniform. It's densest at sea level and gradually thins out as you ascend. Think of it like a giant blanket wrapped around Earth, getting thinner and thinner towards the edges. This gradual thinning of the atmosphere has significant implications for flight. So, where does the atmosphere end and space begin? There's no hard boundary, but scientists have defined an altitude called the Carmen Line as the edge of space. Located about 100 kilometers, 62 miles above sea level, the Carmen Line represents the point where the atmosphere becomes so thin that traditional flight is no longer possible. At this altitude, the air is too thin to provide enough lift for airplanes to stay aloft. Section 5. Thin air and other challenges. Why planes can't go higher. As airplanes climb higher, the thinning air presents several challenges. The atmosphere becomes less dense, which directly impacts the aircraft's performance and safety. First, less air means less lift. Lift is the force that allows an airplane to rise off the ground and stay in the air. It is generated by the movement of air over the wings. When the air is thinner, there are fewer air molecules to create this lift, making it harder for the plane to stay aloft. To maintain altitude, planes need to travel faster, which requires more powerful engines and burns more fuel. This increased fuel consumption is not just a matter of cost, it also affects the range and efficiency of the flight. Pilots and engineers must carefully balance speed, fuel consumption, and altitude to ensure a safe and economical journey. Second, the thinner air also makes it harder for engines to combust fuel efficiently. Combustion is the process of burning fuel to produce energy, and it requires a certain amount of oxygen. At higher altitudes, the reduced oxygen levels mean that engines cannot burn fuel as effectively, leading to a decrease in power and performance. Jet engines, for example, need oxygen from the air to burn fuel and generate thrust. Without sufficient oxygen, the engines struggle to produce the necessary power, which can limit the aircraft's ability to climb higher or maintain speed. Above a certain altitude, the lack of oxygen makes combustion impossible. This is why commercial airplanes typically cruise at altitudes between 30,000 and 40,000 feet, where there is still enough oxygen to support efficient engine operation. Finally, the extreme cold and increased radiation exposure at high altitudes pose significant risks to both aircraft and passengers. The temperature can drop to minus 60 degrees Fahrenheit or lower, which can affect the aircraft's materials and systems. Additionally, higher altitudes expose passengers and crew to more cosmic radiation, which can have long-term health effects. These factors, combined with the challenges of lift and combustion, explain why planes can't go higher. Section 6. Rockets, powerful machines for space travel. Unlike airplanes, which rely on aerodynamic lift generated by their wings, rockets are designed to travel through the vacuum of space. Instead of air-breathing engines, rockets carry their own oxygen supply, allowing them to combust fuel and generate thrust even in the absence of air. This makes them ideal for space travel, where there's no atmosphere to provide lift or support combustion. Section 7. Airplanes and rockets. A tale of two flyers. Think of it this way, airplanes are like swimmers gliding through the water, our atmosphere. They need the water to support and propel them. Rockets, on the other hand, are like submarines. They carry their own environment with them, allowing them to operate independently of the surrounding water. This fundamental difference in design and propulsion is what allows rockets to venture into the vacuum of space, while airplanes are confined to the Earth's atmosphere. Section 8. Gravity's pull, a force to overcome. Another crucial factor in space travel is gravity. Earth's gravity constantly pulls objects towards its center. To escape this gravitational pull and reach space, rockets need to achieve an incredible speed escape velocity. Escape velocity is the minimum speed an object needs to travel to break free from a planet's gravitational pull and continue into space without falling back down. Section 9. The need for speed reaching escape velocity. For Earth, escape velocity is about 11.2 kilometers per second, or 25,000 miles per hour. That's over 30 times the speed of sound. Achieving this incredible speed requires immense power, which is why rockets are equipped with powerful engines and multiple stages that detach as fuel is consumed, reducing the rocket's weight and allowing it to accelerate faster. Section 10. The future of space travel, beyond airplanes and rockets. While airplanes may not be able to take us into space, their development has paved the way for new and innovative forms of space travel. Companies are now exploring hypersonic aircraft that can travel at many times the speed of sound, blurring the lines between traditional airplanes and spacecraft. These advancements, along with reusable rockets and spaceplanes, are making space more accessible and affordable, bringing us closer to a future where space tourism and exploration are commonplace. Section 11. Keep looking up. The universe awaits. So the next time you see an airplane soaring overhead, remember that while it can't take us to space, it represents humanity's enduring fascination with flight and our desire to explore the world around us. And as we continue to push the boundaries of technology, who knows what incredible machines we'll invent next. Keep looking up at the stars, for the universe holds endless possibilities, and our journey of discovery has just begun.